Okay, now it's the easy part, right? We just drag these STL files into our 3D print prep software, arrange them on the bed, and hit print, right? Well, even here with one copy of all of the STLs, I've got about 6 hours worth of printing before me. 2 hours for each of these beds, and I can't guarantee that any of our awesome 3D printers are going to be available at the exact hour that I need it for 2 hours. Sometimes we're doing big production runs in the Makerspace and everything is booked up. So let's talk about a strategy for deciding upon what to print and why that was your choice. Start with who you're working with. Is it just you, which is possible, or is it a small group of about 4 people, which I'd recommend? Start there and decide who is responsible for each of the parts, and then write this down in a Google Sheet so that everybody can see clearly where the responsibility lies. And when doing this, structure a backup plan so that if somebody gets sick and can't meet their responsibilities, someone is ready to swoop in and save the day. Then count all your duplicate parts and get those quantities added to your spreadsheet, and then agree on a calendar. We've got 2 weeks for this project. Seems like a long time, except that the functional mechanism part of the project is actually due in 1 week. That's 7 days from today. Make that visible because it allows you to help make decisions about when to print and why. 2 weeks out is when the improvements to the mechanism and the public presentation is due, and that is a totally impossible target until you have a functional mechanism. So let's start with that first half of the project. Building a calendar can inspire a sort of panic. I must start printing right now in order to meet my deadlines. But take a moment and look into our scrap bin box and see if there are any parts that you can make use of that you don't even have to print. There is no shame in making use of pre-existing materials on your journey towards a design iteration process. And if you'd rather not, no worries. Go ahead and print everything. The scraps are there if they're useful to your process. They're useful to me because I get to go, oh, this is how a collar clamp comes together. And oh, this is the 3/32 hex key that can drive those 440 screws, allowing both halves of the collar clamp to open and close on the shaft of the 1/4-inch pendulum. Perhaps it's helpful to see how a slip knot can secure a piece of yarn to the little slits in the edge of the pulley, making it much easier to wind the string that you'll need to drive the whole mechanism. Maybe it's nice to see the weight in the weight cup so that you can start finding something to add to your own weight cup and start thinking about how much weight might be the right amount. Taking a look at how I tied this weight cup to the bottom by just wrapping the yarn around a loose machine screw that I found on the floor might suggest how this design is in no way complete and that there is plenty of room for the improvements that are asked for in 2 weeks' time. It might be helpful to see the weight cups side by side, one of which holds the majority of the weight while the other rides at the bottom of the shaft of the pendulum. Sometimes it's called the bob of the pendulum. It might even be worth it to think about how are you going to mount this thing high up on the wall so that you can do your testing, asking, is it functional? Does it work? And so you might want to locate some wood, some construction screws, our 1/4-20 machine screws, and the smaller 832 machine screws and their corresponding hex nuts and lock nuts. Find the T25 star bit for the construction screws. Find the impact driver and learn how to load the bit into it. Gathering all your tools and supplies and spare parts really clarifies all the pieces of the puzzle that go into a final functional mechanism, and hopefully clarifies why today or tonight is the time to start 3D printing and why by tomorrow you really want to be wrapping it up, because you need a chance to perform a first assembly to see whether that works or not, to ask how well it works, and to have a chance to disassemble, make edits, reprint anything that failed, and then do a final assembly in time for the deadline. With the big catch being that 3D printing takes time. You can't just hit the print button and then pull the sheet of paper out of the printer seconds later. It takes time, usually on the order of hours, which is why we plan for it so carefully with a calendar and with strategic choices about what exactly we're going to print, which is what we're going to do next.